Hello, hi everyone. So today we are going to learn about what are the top 10 libraries for Python beginners, right? If you're starting your career in data science, or maybe you are starting with Python programming to use it for data science and machine learning, this is going to be really great for you because I'm going to, walk you guys through what are the top 10 libraries which everybody should be aware of in order to code in Python for data science and machine learning applications, right? If you're building data science models, machine learning models, if you're even doing any statistical tests, right? Or just building some visualizations for statistical reports or analytical reports, right? This is going to be really good for you. If you start with these libraries and then dive deeper into those, understand what these libraries do, how can they help you, what are their usage, what are the features, right? So let's go and I'll just walk you through all these things. Okay, guys? Thank you. Okay, so top 10 Python libraries. Before starting with the topic, right, let me introduce myself. Where do I come from? What is my background? What is my years of experience? And what kind of projects I've done? So uh, I'm Nishit Jain. Right now, I'm working as a senior data science manager at eClerx. Uh, I almost have around 6 years of relevant work experience in machine learning and data science. I've worked for Fortune 500 clients and also startups building ML systems for them, also setting up their analytics unit uh, and doing a lot of forecasting stuff and everything, right? Uh, Being from data science, most of the people start with Python, and hence I did. I started with Python in my engineering, right? I have solved business problems for multitude of domains, right? Starting from manufacturing, media, as you can see, entertainment, e-commerce, etc. Wherein I've used forecasting algorithms, I built recommender systems, prediction regression algorithms as well. Correct. And the fun fact is most of these top 10 libraries which I put in the list are from my experience, guys. And literally, I have used them practically for industry-wide applications, and they are being used right now when we talk about it, right? Yes. So diving deeper into it, actually, for the absolute beginners, right, who have no experience in Python coding or, for that matter, any programming language. So, what would be a Python library? When you talk about a package or what is a Python library? Python libraries are basically a bundle of functions and classes which basically contain some standard template code, right, to perform a specific operation or maybe just to design your code in a better way and so that you can do it in a standardized way, right? So there are, if you can see the number, right, there are more than 137,000 libraries at present when we talk about it in Python, which basically play a vital role in developing machine learning, data science, natural language processing, deep learning, any kind of visualization, image processing, video processing. We have libraries for multitude of use cases. Now, why do we need these libraries? Why can't we code them from scratch? We can do that, right? Everything can be coded from scratch, but then your development time will rise exponentially if you're not using any libraries, right? These libraries are designed in such a way that they are already optimize your code, they help you standardize your code, and they help you beautify your code and make it concise, and they help you abstract all the details which are not needed for the end user, right, or for the developer for that matter, so that you can use those functionalities and those features which are being repeatedly used out of the box. You don't have to deal with them from the scratch, correct? Yes. So now, if you talk about advantages of having libraries and why do we use it, as I said, it actually improves your speed of development, right? It ensures that you're using code optimization. You don't have to worry about for most of the things until it is really customized. For most of the things, you don't have to really worry about whether my code is optimized or not, because if you're using a library, uh, be rest assured that it is most of the times going to be optimized, correct? Uh, and most of all, it offers you abstraction of implementation, which is basically you don't have to worry about finer details in how this is being implemented from scratch until it is a really new discovery from your end, or you're a research person who's developing a new algorithm altogether. You might have to write code from scratch in that case, but until you're using predefined, pre-implemented, and already developed algorithms, and you're just implementing them for your use case, it is really recommended that you use a library. And for that matter, we are going to go through these top 10 libraries, wherein you would hardly feel any need for using any other library unless there's a very specific exception. Okay, so let's get into it. The first one on the list, of course, is everybody's, you can say, the first library when they encounter Python for data science is NumPy. NumPy basically is the fundamental package for mathematical computing in Python. When I say what is mathematical computing, guys, so it offers almost, I will say almost every mathematical function implemented in this library. If you are thinking of a function to implement in Python, which is mathematical in nature, when I say mathematical functions, it can be trigonometric functions, it can be geometric function, it can be algebra as well, right? So all these functions you will find pre-implemented in this library, which you can use out of the box with minimal to no customization. And that's the beauty of this library. This is really fast. This actually uses a C to C++ background, backend, which basically makes compute really fast, right? And it actually provides you capability to deal with continuous numbers. It also helps you deal with vectors, multi-dimensional arrays, as mentioned, right? And you can do a lot of stuff with matrices as well, right? So it also offers you fast operations in I/O, like Fourier transforms, basic linear algebra, basic statistical operations, random simulation, and much more. Right on the right-hand side, you can see we have implemented a very specific snippet of this code. How do you implement it, right? You just have to import it as NumPy as NP, which is kind of a tradition that you always import a library with its initials, right? You have a fixed initial for every library, which in this case is NP, right? Then you have initialized an array, right? It's a kind of a 1D array. And then we are printing the array, and then we are finding the index when the value of that array is 30, right? This code simply prints the index of the number 30, which in this case would be 2, correct? So this is just a glimpse of how we implement and how can we use NumPy. In this similar fashion, you can use a lot of functions which are available in NumPy, right? The next on list is SciPy. As we have NumPy for mathematical computing, SciPy is mostly for scientific computing. All of the scientific functions which you might need for the research purposes, for some experimental purposes, you would really find them here. And this is really a good library. You won't believe NumPy and SciPy together are backend for most of the functions in some advanced libraries, which you will be seeing in next in the list. Okay, coming to the functions and supports that SciPy provides, right? It's more about integration. As I said, all the scientific computing, which is integration, differentiation, interpolation, eigenvalue problems, algebraic equations, differential equations. I mean, I'm sure if you might have already heard of integration and differential, how difficult it was in your maybe 12th standard, right? People used to merely be scared of these things, right? But over here, when you are computing, right, when you're doing Python coding, you don't have to do integrations from scratch as you used to do in your 12th, right? So that's when SciPy comes into picture. And you can basically do integration and solve differential equations using SciPy. And this is really a miracle, right? Because a lot, as I mentioned, right? So a lot of high level or complex algorithms in machine learning do use these techniques wherein you have to continuously implement them in order to reach a solution. Now, as I mentioned, right, so algorithms, data structures provided by SciPy are broadly applicable across domains. Why? Because these are also being used for developing multiple algorithms, correct? It also extends NumPy, providing additional tools for array computing and provides specialized data structures such as matrices and k-dimensional trees. So this is a more advanced version of SciPy in some sense as well, so of NumPy in some sense as well. But still, it also provides extensive scientific computing. And that is why we have a different library, and it's named, of course, SciPy. Correct. It is highly optimized implementation written in low-level language, as I mentioned, right, in C, C++, and you can enjoy the flexibility of Python with the speed of compile code. So you have a speed of C and C++ with the easy programming notations of Python, right, which is really great in our case. On the right-hand side, I've just given an explanation of a few functions. So in the top, you can see we are importing SciPy. From SciPy, we are importing some specials. Special is a sub package of SciPy, which basically helps you implement some special functions, right? When I say exponential functions, then we have sine. We are finding sine of 90. We are finding cos of 45, correct? And this will exactly give you results which is expected. So you can basically find sine of any angle, cos of any angle. So these are some trigonometric functions which are basically used in a lot of cases. So next on list is Pandas. Pandas is something which is, I can say, holy grail of data analysis. Any structured or tabular data analysis has to start with Pandas. And this is not written anywhere, but this is unsaid fact. When you're dealing with data science, you have to do pandas. Pandas is basically, you can say, it's where every tabular data analysis starts, correct? What ends at Excel gets into Pandas, because Excel has a limitation, Pandas does not. Pandas can, you know, although it might take time because it's not distributed in nature, but yes, Pandas has a capability of expanding your models. You can basically do any sort of EDA data analysis using Pandas. It offers you multiple types of functionalities wherein you can run any type of functions, string related to string manipulations, number manipulations, analyzing data, correlations, and whatnot, and basic visualizations as well. It also contains capability to draw basic graphs as well, right? Now, to think about it, it also provides you IO operations where you can read a file from Excel and then save it into CSV or vice versa. You can also change the formats. You might want to, save a file which is very big in size because it's Excel, and then you want to save it in a byte format, right? Which would reduce its size. So you can do all sorts of IO operations inside Pandas as well. And it's a really flexible library which offers you a lot of functionalities to explore your data that you might not need to reach outside for some other help, right? There are a lot of slicing, dicing, all sorts of operations which you also expect from SQL and Excel are already there, and much more. On the right hand side, you can see a code snippet wherein we basically are trying to, we have a JSON and we are trying to convert it into data frame. Data frames are nothing but what you call tables in SQL, right? In SQL, you run select star from table name, right? Then you get a table. So that's what we call data frame. And df.head would do the same thing for you. So it's like select star from table name, limit whatever we pass. That's what we do df.head, right? You create a data frame first. So a entire table would be called data frame. A single column would be called a series in Pandas. Next on list is Sci-Kit Learn. So now in Pandas, you were basically able to do data analysis, right? Data analysis, like crunching data in any shape and form, all sorts of visualizations you want to do, all sorts of data analysis you could do in EDA. So that's the first step when you start with any machine learning model or any exploratory analysis. You have to do data analysis, right? Without which there is no machine learning. You have to understand data, and that's when Pandas come into picture. Once you are done with analysis, right, you have to move to the next step, which is building a model or implementing a machine learning algorithm to see how much performance you are getting, right? So that's when Sci-Kit Learn, which is a library which provides you implementations of machine learning algorithms out of the box. For example, linear regression, logistic regression, decision trees, random forest, support vector machines, all these algorithms which you might have heard of in theory can be implemented using Sci-Kit Learn. This is a really great library for implementing those algorithms, and they can be implemented with so easy syntax and so out of the box that you have to really almost do nothing, right? So as I said, right, it's a kind of open source library. Obviously, it offers you machine learning algorithm implementations of supervised and unsupervised algorithms, right? It has regression, clustering, model selection, classification, dimensionality reduction, all sorts of algorithms. It also helps you build that model. You simply say dot fit and data, dot predict on data, right? So these are, again, an examples of abstraction of implementation, as we saw what is in the what is a Python library section. That abstraction of implementation is a really important thing which drives people to coding, and it is really important to speed up your development process. Correct? Now, once you build a model, what do you do with it? You can't just keep building model again and again on the same data, right? So it also offers you IO operations with model as well. You can save your model, you can load your model, and you can use that model again to predict on new sets of data points, right? And also the fun fact about Sci-Kit Learn would be before deep learning came into picture, when deep learning was still in the research phase, right? It was Sci-Kit Learn who was driving a lot of machine learning until deep learning became productionalized. So basically, deep learning actually I started adding real value to the businesses, right? NLTK is like, you can say, it's a pandas. It's actually a pandas for text data, right? When you have a lot of text, not every data is going to be table, right? You can't have every data into a rows and columns format. There can be paragraphs, there can be books which can be scanned, which can be structured. So you can have a PDF. If you have a lot of text data, what do you do with it? It's also data, right? How do you analyze sentiments? What is written in it? So NLTK is something which actually helps you analyze the text data. How many words are there? What kinds of words are there? What is the frequency of word? You can draw a word cloud. You can in fact split your paragraphs into sentences into words, and analyze n-grams, and what is the frequency of those, what kinds of words are being used the most. You can do a lot of all sorts of basic text related analysis and text related crunching of data using this library, wherein you can also extract parts of speech. For example, what is a noun, what is a pronoun, and sort of dependency parsing. But dependency parsing is all something which is basically, these are all sorts of related to grammar, and you can analyze the entire grammar of the language using NLTK. Okay, as I mentioned, the way we use Pandas for analyzing tabular data is structured data, right? Similarly, we can use NLTK for analyzing unstructured text data for all sorts of analysis and cleaning, right? So before before you move on to modeling anything, you have to actually clean your data in such a way that it is standardized and a model can understand it, right? So that's when these libraries like Pandas and NLTK can be used for your smaller purposes, right? But when you move into production, you have to build specialized data pipelines which can feed your data back into the model, which is being trained, or maybe during active training and everything, right? So you have to build a specialized data pipeline wherein you have to write some more code. And but for initial purposes, when you're building a small scale model or anything, and in fact, when you are trying to experiment and evaluate your POCs and everything, these libraries are really important, right? Again, then comes, once you are done with NLTK, I would say next on the list would be FastAPI. FastAPI is a library. It actually justifies its name. API development is a very core aspect of deploying any machine learning model. And I do not expect every data scientist to learn API development, but you should be aware of how things are working, right? And FastAPI is a great Python library which can help you basically do initial sorts of POCs, right? It's a very the learning curve is not that steep. It's really flat. The codes are really easy to deploy, and it gets you up and started in minutes. I can say that because I've worked on this thing, right? I've used this FastAPI library for my initial purposes before getting before involving all the API developers and everything, and then getting my model into production. I do this analysis myself so that I can explain them what kind of API I need, what kind of data would be the input, what would be the output, and how will it flow through the API. So that is something which it helps me do that. This also is being used by a lot of developers in production because it is really fast to scale, fast to deploy, and fast to develop. So those are its, you can say it's very fast to code. It is really short. The code is really short in nature, wherein we can use it. It has fewer bugs. It is really robust. The architecture behind FastAPI is built in such a way that it really requires a lot less coding and does more stuff. Correct. On the right hand side, if you can see, I am just deploying a very small API which would be deployed on your local computer as a server, which would say just say hello world, right? And that's it. So you just need these 5 lines of code to create an API. And then you can put your logic inside it. You can create a function. In this case, it is root. Root can call some different functions, and maybe you can, for all your model inferences also, you can use this code and you can deploy it on. It is as easy as this. Okay, this looks, right, to deploy it on the server as well. Next in line would be Plotly. Now, Plotly is really beautiful library to create some magical plots. When I say plots, it's about the visualization graphs which you want to deploy. So now, how can you use Plotly? Why Plotly? There are multiple other libraries, Seaborn, Matplotlly, but I chose Plotly because Plotly has multitude of applications. You can create graphs on Jupyter. You can also create graphs on web apps, right? Let's say you have your leadership and your leadership wants to see a report. You're not just going to give them numbers. You can create a beautiful report with all the visualizations, which gives them in a complete picture. When they can see the insights at a glance. They don't have to scroll through numbers and scrap through numbers. They can look at the graph, which is really beautiful. They don't have to worry about the code because you can't take a Jupyter notebook to your leadership and tell them, okay, this code does this. Doesn't make sense, right? Plotly helps you really, without any web developer, you can create those intuitive and those beautiful reports. Yeah. Plotly basically also has a unique sets of
40 unique charts you can see, right, which covers a wide range of statistical, financial, geographic, scientific, and multiple use cases, right? You can in fact draw uh, chloropath graphs, which is basically, if you want to show some geographical information like geospatial information, it's really intuitive to show them using a map, correct, rather than using some tables or charts. So that is something which Plotly offers you out of the box. You don't have to do anything. It also helps you, download multiple graphs if you want to do it offline, and you can download it from their web and you can just do it, right? So it has a lot of expandable capabilities, and the graphs are really interactive. That is not the case with Matplotlib and Seaborn, as they are very basic libraries. Plotly is something which doesn't have a big learning curve, and also offers you interactive graphs. Once you implement it, you'll see it. Streamlit would be a very advanced library. Why? Because Streamlit is something which helps you develop web apps without being a web developer yourself. And I'm not just kidding here, because it is really a good library. You can write Python code, and your Python code gets converted into a web app, and it is really nice, right? You say, I want to create a button in Python, and it really creates a button on the web app. So you can basically create a small web app to showcase your use case to to your audience, and then before deploying it to production, you can create a small prototype of it if you want to prototype something, and quick prototyping and showcasing it to your leadership, your fellow colleagues, your manager, and making basically proving your point that your model is really working, and this is how the results are going to get. This prototype can also help web developers build the kind of API they want, and this is really quick to build, right? You don't have to depend on anything, not anyone. You don't have to learn anything new, right? You don't have to learn a new programming language. You can do the same thing in Python, but it will give you a good output in form of a web application, right? And not just that, you can also deploy this application on any server whatsoever, and anybody who wants to use and see the use case can use it. So that's the beauty of it. Correct. So if you look at it, it's really easy. So what I'm doing over here is I'm just writing st.title. So first of all, I'm import Streamlit as st, right? As I said, we always have initials before importing a library. So when I say st.title, Uber pickups in NYC. And when I say in the command prompt, I run Streamlit run Uber pickups.py, correct? So what it does is basically it's going to create an empty web page, and the title of the web page on the browser would be Uber pickups in NYC, which is really saying, writing HTML, then title and everything, right? So it is basically converting your Python code into HTML and putting it into web and creating a sort of, you can say, a website or a web application itself, right? Now you can do much more than this one. Like I could have put a button, I could have put a text box, I could have put an input text box and take input from the user, submit it to my model and get inferences and publish them back to the web app, right? So these are all very, very smooth and requires minimum code when doing this with Streamlit. Correct. Next in list is Keras, right? Until now, Sci-Kit Learn and everything we did, those implemented basic machine learning algorithms. So not basic machine learning algorithms, right? But when you use Keras helps you actually implement deep learning, right? So when you want to compile and build models to use deep learning neural networks, right? The first step to start is Keras. Keras actually offers a really intuitive way to create models, right? It's not that difficult. The structure is really easy. The way you create models is really easy, and it's a really good API to provide. I think it can cover at least 80% of what you do in deep learning, or whatever you will do in deep learning in your career can be covered by Keras. Keras has multiple options to customize your model as well. If you want to do it, you can write your own custom functions as well for loss function, for everything. Once you get into deep learning, that is really going to be good for you. If you look at it, I have put a very, very simple code sample of Keras, right? Where I'm importing Keras from TensorFlow. So basically, Keras was a separate library before, but then it got integrated with TensorFlow. But still, I prefer to suggest Keras as a different library and TensorFlow as a different library, because there is a hell lot of difference, right? Now, if you see, creating a model is as easy as creating these layers, right? These are neural network layers. You just have to keep on adding those layers to the model, and then you say model.summary, and then you build it, right? So this is really easy. It doesn't get that easy when you use TensorFlow, but TensorFlow has its own advantages and Keras has its own advantage, because when you're beginning into deep learning, I would suggest everybody to go through Keras to build that confidence and that understanding, and that and learn how intuitive it is, right? And then you can get into deeper layers and deeper details of it. Correct. On the left hand side, you can see it is really simple, flexible, powerful, and you can use it to build. As I said, 80% types of the deep learning models you will encounter in your career, right? Next in list, as I mentioned, right, when you get very comfortable with Keras, right, you should move on to TensorFlow. Now, TensorFlow also has an option PyTorch. It can be its twin brother, correct? But I feel when you're learning Keras, you should go with TensorFlow. TensorFlow is a library which was released by Google, right? And it was released. It's kind of a, you can say, you can do all sorts of customizations. It has a multitude of support, right? I feel it has a lot of supports. You can build TensorFlow data pipelines. You can build TensorFlow recommender systems out of the box. They provide you APIs for all those tasks, and these actually provide you these APIs in such a way that you don't have to worry about the details of it, right? And they work really good out of the box, and it is open source. What else you need? Correct. Now, if you look at TensorFlow, right, it also offers you data storage, data pipelines, model building, model deployment, model serving, model monitoring, and recommender systems API out of the box. And you go and on top of it, you have support for distributed training as well. When you want to scale, right, you really can use distributed training support. So that brings us to the end of the video, right? And the lecture ends here. But before saying bye-bye, let me also walk you through what all other useful libraries you might want to consider, right? PyTorch is a good substitute for deep learning models. PyTorch was developed by Facebook, right? That's the only difference, I think. What all you can do in PyTorch can also be possible in TensorFlow and vice versa. Spacey, Gensim are next stages. When you are done with NLTK, as we discussed, I would suggest you go through some advanced libraries which are Spacey and Gensim, which offer a lot of different functionalities which are not available in NLTK, right? Some other smaller substitutes, if you don't want to do much interactive graphs and everything, and you want to just display this information for your own benefit, I would suggest going for Matplotlib, Seaborn, and Transformers. Transformers is something which I suggest everybody should go through if they want to, specialize in NLP and NLP related applications, because Transformers offers a lot of models out of the box. It offers pre-training. It also offers transfer learning, and all these concepts are covered really well in Transformers. It is developed by Hugging Face, right? And it should be your next go-to option for libraries to learn and to practice code in after you are done with the basic libraries which I mentioned for NLP, right? OpenCV is something which is purpose built for image processing, right? It has a lot of, so as we have NumPy for numbers, we have OpenCV for images. That's as easier I can explain it, right? As easy as I can. And OpenCV has, I think, most of the functionalities which we need for image processing, as I've observed in my career, right? Whenever you're developing, when you're working with images, right, maybe doing some sort of image processing, you will always have to use OpenCV, and that is what most of the developers have been using, right? That's where you start. On the way, you might encounter a lot of new libraries as well. So there were Pillow, then there came OpenCV, then there is a Tesseract as well, right? So there are a hell lot of libraries, but OpenCV is a kind of holy grail for image processing, which is being, I think, which has been offering a lot of solutions, and people have been using it extensively everywhere. I think that's all for this one. Thanks, everyone. I'll see you in the next week. Thank you.